Amid the rapidly accelerating wave of global electric vehicle innovation, Toyota has suddenly shifted the spotlight back to the core of energy technology, announcing that it is advancing a breakthrough that could fundamentally redefine the way we travel, and that breakthrough is the long-awaited yet notoriously difficult to mass-produce solid-state battery. Solid-state batteries are considered the ultimate form of battery technology because they promise higher energy density, faster charging, greater safety, and significantly longer lifespan, offering the potential to transform the electric vehicle experience from the ground up. Traditional lithium-ion batteries rely on flammable liquid electrolytes, which naturally introduce risks of thermal runaway and accelerated degradation, while solid-state batteries replace the liquid with a solid electrolyte, creating a more stable internal structure capable of withstanding higher temperatures and pressure. Toyota is currently pursuing the sulfide-based solid electrolyte route, a material known for its extremely high ionic conductivity, allowing lithium ions to move faster during charge and discharge while maintaining strong safety performance, making it one of the most promising technologies in the industry. However, sulfide solid electrolytes are notoriously difficult to mass produce, requiring manufacturing in extremely low humidity environments and flawless interface bonding, because even microscopic contamination or gaps can significantly reduce the battery's overall performance. To overcome the industry's biggest challenge, interface degradation, Toyota has partnered with Sumitomo Metal Mining to develop highly durable cathode materials, using advanced powder engineering to ensure long-term stability even at high energy densities. At the same time, Toyota is working with Idemitsu Kozen to establish mass production capability for critical raw materials such as lithium sulfide, because bringing solid-state batteries to the automotive market requires far more than small-scale lab production. A full supply chain must be built a decade in advance. These invisible materials, powders, chemical reactions, and precision manufacturing steps are the real battleground for solid-state battery commercialization, and Toyota is clearly taking a pragmatic, long-term approach to building the entire ecosystem required for future mass production. The timeline is what the public watches most closely, and Toyota has set a target of launching its first mass-produced solid-state battery vehicle around 2027 to 2028, though this date is not guaranteed, as numerous engineering challenges and yield issues still need to be solved. Every factor from electrolyte pressing methods, electrode interface quality, stacking precision, to the stability of a fully scaled-up production line will determine whether solid-state batteries can truly be mass-produced rather than remain a showpiece technology. If these challenges are ultimately overcome, solid-state EVs could achieve ranges far beyond today's standards, potentially reaching a theoretical 800 to 1,000 kilometers, making long-distance travel much more effortless. Their fast charging capability is also highly anticipated, as the low-impedance solid electrolyte allows lithium ions to move freely, enabling large amounts of energy to be replenished in a very short time, possibly achieving an 80% charge in around 10 minutes. Furthermore, the inherently stable structure and reduced swelling and dendrite formation mean solid-state batteries can endure many more full charge-discharge cycles, extending vehicle lifespan and reducing performance degradation over time. A longer battery lifespan may also reshape the entire used car market, as battery degradation would no longer be the biggest drawback for EVs, making vehicle value more reflective of real-world usage rather than battery aging. Improved safety is another major advantage, since the solid electrolyte is non-flammable and reduces the risks of thermal runaway, fires, and explosions, making high-voltage system design simpler and giving drivers more confidence in rapid charging. As solid-state batteries become more common, the size, shape, and structural design of battery packs may be dramatically reimagined, because the lack of liquid components eliminates the need for multiple protective layers, freeing designers to rethink vehicle chassis layouts. This flexibility allows designers to create lighter, stiffer, and more space-efficient vehicle bodies, and these improvements will ultimately benefit consumers, bringing entirely new possibilities to EV aesthetics and interior experiences. However, we must not overlook the cost challenges, as raw material procurement, specialized equipment, advanced manufacturing processes, and extreme environmental controls will make early production expensive, likely limiting the first generation to mid to high-end models. As technology matures, yields improve, supply chains scale, and industry standards form, the cost of solid-state batteries may gradually decrease, allowing more affordable models to adopt the technology and pushing the entire market to upgrade. Globally, many companies are also entering the solid-state race, with major players in Korea, Japan, Europe, and China vigorously developing competing material systems, making this technological contest unpredictable and highly dynamic. Different companies are pursuing oxide-based, polymer-based, and hybrid solid-state batteries, each with strengths and weaknesses, and the eventual winner may not be the one with the strongest theoretical performance, but the one that can scale and manufacture at competitive cost. In this race, Toyota's advantage lies not only in technology itself, but also in its immense manufacturing capability, mature quality control systems, and deep integration with the supply chain, giving it a strong chance to lead during the mass production phase. If commercialized, solid-state batteries could accelerate the global energy transition, as longer range and faster charging reduce dependence on public charging networks, helping EVs spread more easily across both cities and rural regions. Their stability and long cycle life could also benefit renewable energy storage systems, enabling safer and more durable storage for wind and solar energy, strengthening grid flexibility and reliability. On the industry side, solid-state batteries may reorganize the entire supply chain landscape, creating new opportunities for advanced materials companies, specialized equipment makers, and high-end chemical manufacturers, attracting substantial investment into the sector. Consumers will also benefit, as longer warranties, lower degradation, more stable fast charging performance, and safer vehicle structures will make EV ownership more cost-effective and more comparable to traditional gasoline cars. Of course, solid-state batteries still face many uncertainties, including whether production lines can be built on schedule, whether raw materials can be stably supplied, whether new engineering bottlenecks will emerge, and whether fast charging will introduce new interface challenges. Even so, progress over the past 5 years has far exceeded expectations, with breakthroughs in materials, durability, and manufacturing technologies turning mass production from maybe into possible, bringing solid-state batteries closer to reality. If Toyota successfully launches its first solid-state battery vehicles in 2027 to 2028, it will mark the beginning of a new era for the global EV industry, setting a fresh benchmark for technology and competition. We cannot yet predict whether solid-state batteries will completely replace liquid lithium-ion batteries, but what is certain is that they have already become a critical strategic direction for automakers and tech companies worldwide, shaping the next decade of innovation. For consumers, solid-state batteries represent an era of faster charging, longer range, greater safety, and far better durability, shifting EVs from viable to superior, allowing people to truly feel the lifestyle improvements brought by technological progress. Ultimately, whether solid-state batteries become part of our everyday lives will depend on whether technology, supply chains, markets, and policies mature in sync, and this grand adventure spanning materials science, manufacturing engineering, and the automotive industry is one we should all continue to watch closely.